Today we are going to discuss an instrument called scintillator. But before we start, we must first define what radiation is. Radiation is an emission of energy or electromagnetic waves or moving subatomic particles which causes ionization from high-energy particles. Nowadays, we all know the importance of radiation when it comes to different industries, especially in the healthcare field. We use radiation to diagnose and treat diseases. These are the several types of procedure that benefits the use of radiation to properly diagnose various types of diseases. This includes conventional X-ray, CT scan, mammography, PET scan, and many others. However, we should accept the fact that the use of radiation is technically dangerous because it can interfere with the natural process of the body. That is why we need radiation protection to apply in every field that uses ionizing radiation. In the healthcare setting and other industries, if they use radiation, they should have in-depth knowledge about it and its limitation. The general rule that can be applied is the principle of ALARA, which is known as low as reasonably achievable. To apply this principle, we must remember three simple words: time, distance, and shielding. We must reduce the time for exposure. We have to have an acceptable distance during the procedure, and shielding to ensure the safety of the personnel and the patient. The main concept behind this rule is that it can help prevent both unnecessary exposure and overexposure to ionizing radiation. Furthermore, in radiation services in a hospital, we use different types of devices and shields, such as lead shields and collimators to reduce radiation exposure. While on other industries, there are other equipment and devices like detectors that can be used to measure radiation. For today, we will be focusing on a device called scintillation counter or scintillation detector, which can be used for area monitoring. This device is a radiation detector that uses the effect known as scintillation. Scintillation is a flash of light produced in a transparent material by passing a particle, an electron, an alpha particle, an ion, or a high-energy photon. Scintillation occurs in the scintillator, a key part of scintillation detector. In general, a scintillation detector consists of scintillator. A scintillator generates photons in response to incident radiation. Second, photodetector. A sensitive photodetector like a charge-coupled device, camera, or a photodiode that converts the light to an electrical signal, and electronics process the signal. The principle behind this device is that it involves radiation that reacts with scintillator that produces a series of flashes with varying intensity. The intensity of the flashes is proportional to the energy of the radiation. This means that the higher or lower the intensity of the flashes can determine the measurement of the energy of gamma radiation. The intensity of the flashes and the amplitude of the output voltage pulse are proportional to the energy of the radiation. Scintillation counter are commonly used for radiation protection because of the good efficiency, and it can both measure the intensity and the energy of the incident radiation. In addition, some advantages of using this device is that it has a high precision and counting rates that is extremely beneficial for surveys. In hospitals, there are gamma cameras that are based on scintillation effects to determine radiation. These are also called scintillation cameras. This is a basic information about radiation detectors that focuses on scintillator devices. If you want to find out more, you can check out other videos in our channel. That is all. Thank you for listening. Thank you for watching.